Good afternoon. Hope everyone's having a great day so far. Today I'm going to be talking to you about editor scripting in Unity. Before I get going, quick little introduction about myself. I'm Tech Senior Solutions Engineer at Unity Singapore. I have actually been a technical artist for most of my career prior to joining Unity, and part of that job, or a big part of that job, was building custom tools for artists, for designers, fellow developers, and that's actually one of the main reasons I've sort of used Unity so much, is that it provides a lot of really powerful hooks into the editor to create these custom tools or modify pipelines. So jumping right in, what is editor scripting? So in a nutshell, we're basically looking at a collection of C# APIs to customize the editor to better suit your workflow. These can cover quite a lot of stuff. There's custom inspectors. These allow you to inspect your data and interact with your data in a more custom way, in a way that's more suited to your workflow. There's editor windows, toolbars, overlays, which are one of the new systems that we have to streamline your development. These can be used to build little tools. There's also custom importers, and these allow you to handle either arbitrary or proprietary file types, or automate your imports for specific workflows. Now, a couple of examples of things that you can build with a bit of time and effort. This is a vertex painter that I did several years ago. It essentially hooks into the scene drawing API, and this allows me to draw gizmos to the scene, draw handles, and interact with the actual objects in the scene. All right, so I'm casting against a mesh, and I'm modifying the vertex color data as I paint. This one, the previous one I can't share because it was something I did on the clock at a previous studio. This one I can share a link to. It's on my GitHub. And this is an example of the editor tool API. And this allows you to draw to the scene. It has a specific interface niceties, like the fact that you can have these, your own gizmos, and they show up in this little tool, the tool shelf. And this particular tool allows you to, set temporary custom pivots so that you can rotate or position things in ways that you normally wouldn't, without having to create extra, empties to rotate and scale things around. This, again, I can't share, but this is basically an editor window example that lets you kind of walk backwards and forwards through the dependency network of assets. So you can see what an asset depends on and what depends on this asset. Similarly, this one is something I built to make racetracks. Just uses splines and a bunch of custom editor code, both in the inspector as well as in the scene view, to allow you to use these splines to build racetracks and spawn things like fences, trees, all sorts of vegetation, other props around. This was something that I built with a couple of mates for Hack Week. Basically, just really the whole idea was building a tool to let you do pixel art in the editor rather than going out to an external program and importing your sprites. So the whole idea was that you'd have a custom pixel art format that was purely runtime and an editor window that allowed you to actually author this pixel art. So you can get fairly involved in terms of how deep you go in with your editor scripting. So what is being covered today? Now, editor scripting is a really large topic. I mean, really large. I've done editor scripting for years now. I think over a decade now. And I'm still learning new things. Still learning new ways to do things. And the editor sort of scripting API is expanding constantly. So covering the ins and outs of, editor scripting in as a whole is beyond the scope of a 1-hour webinar. But we'll cover a bit of the mindset planning, and we'll go into some examples, as far as I can go. So when I talk about mindset and planning, this part is actually really super important, mainly because you don't want to go in, especially in a production environment, you don't want to go in half-cooked. You do want to kind of figure out before you start, what problem am I solving? A lot of this will come down to either talking to your users, fellow devs, fellow artists. If you're a solo dev, you'll know pretty well what your problems are, where your bottlenecks lie in your production pipeline. If you're not a solo dev, talking to your users, observing them is really important, because sometimes what they vocalize as the problems that they need solved aren't necessarily the problems that they actually need solving. Another good question to ask yourself is, do I really need to? Do I really need to build a tool? Do I really need to put in this effort to automate this process? This XKCD comic is always a good one. How much effort do I put in? Not just developing, but a lot of people also kind of forget the maintenance aspect. There's a huge maintenance aspect as you build tools. Another thing is really, is this problem already solved? Is there a tool? Is there an editor script already available on the asset store or on GitHub that meets my needs? Odin Inspector is a great example of something that is robust, it's mature, and it will handle a lot of needs, just because it's got a lot of custom editor code. And does the editor itself provide, the functionality that I need? I'll go in a bit later on these, but things like OnValidate, things like the built-in attributes like range. So that's it. If you do need to build things, then this talk will give you it'll get your feet wet as to what you can do with editor scripting. So going into this, we'll look at it in, I guess, roughly in increasing complexity. So first thing I'm going to talk about is OnValidate and OnDraw Gizmos. So these technically fall under editor scripting, as they do run only in the editor. They don't run, in a runtime build. They only run in the editor. But technically they live on the monobehavior. They're implemented as monobehavior methods. They just only run in the editor. So OnValidate is called only when a property is changed in the inspector. And that's the only time. And when the script gets loaded. It does not get called if a script changes a value. Only the inspector. OnDraw Gizmos and OnDraw Gizmos selected. So those are drawn in the scene view, optionally the game view. and they allow you to draw useful information, visualize otherwise invisible information. And the really cool thing is that everything that you draw in this method is pickable. And we'll have a concrete example later. Undo management is actually really important as far as user experience is concerned. I've seen many editor scripts that don't implement undo, or they implement it incorrectly. And that becomes really frustrating when you, as a user or as a developer, you're modifying something and you hit undo expecting to undo those changes, but you end up undoing something completely different because there were no undo states being stored. So I'll get into this a little bit later, but serialized property automatically will handle undo and redo. Otherwise, there's an undo class that allows you to manually handle this. So, as alluded to, serialized object and serialized property. So these allow you to kind of ignore some of the stuff, some of the manual stuff that you might need to do otherwise. Undo management is a big one. Property field in your editor GUI layout will automatically pick the correct property type or the correct field type. So whether that's a slider or a float field, so you don't really need to kind of write code to, say I want to have an object picker or a float field. The property field will automatically pick the right one. And yeah, the undo handling is automatic, which is really nice. One thing here is we have essentially two ways to do editor tools, editor scripting. One is the legacy version, which is IMGUI, immediate mode. And the new version, which is our UI toolkit or UI elements. Now, the immediate mode GUI is sort of the traditional legacy way of building editor interfaces. Immediate mode, it refreshes multiple times per frame. It's very direct, it's very straightforward. It's really quick to prototype things because whatever you draw at the time, you know what its data, what its value is because you're drawing it right there and then. UI toolkit, UI elements is our retained mode interface system. It's probably most similar to like a web style UI where you have a UXML file, which is your document, and then you have a USS, which is our version of CSS, Unity style sheets. And this allows you to separate content, functionality, and styling. So this is really nice because you can work on all of your functionality and all of your content, and then either work on the styling later. You can even hand off the styling or work in parallel with a UI designer. So that's really useful. Now, a couple of useful additions to your tool belt, like once we've gone through all of this, it's worth looking up system.link and system.reflection. These are pure C# namespaces, classes, and these will allow you to do things that you wouldn't necessarily be able to do with the built-in Unity API. So link and reflection are things that you wouldn't necessarily use a lot at runtime, just because they tend to generate a lot of garbage. They're not necessarily super fast, especially if we're doing them a lot. But the nice thing about editor side scripting is that you're a lot less constrained by performance concerns. You're not dealing with runtime code where you're looking at, okay, how much of my 16 or 33 milliseconds is my code taking up? That's a huge concern at runtime. Memory, garbage collection, all that. That's a huge concern at runtime. Less so if you're doing editor tools. You don't want to go overboard You don't want to eat up 2 gigs of memory on a single operation, but you're not as constrained. You can do stuff that's slow, as long as overall, you're saving time. First thing we're going to talk about is OnValidate. Now, OnValidate is a super useful function because it's one of the magic methods similar to awake, start, update that lives on a monobehavior that gets called automatically if you have it implemented. And implementing it, because it's a magic method, is as straightforward as just defining it. So OnValidate, as mentioned in the slides, sort of falls under editor scripting, as it's something that only runs in the editor. But it's something that lives on the monobehavior. So what we have here, as an example, is a camera helper. And all it does is it defines a camera and a follow position as an offset. And currently, I have it set up so that every frame in runtime, as well as in the editor, it will update the camera based on the follow position that we've set. So you'll see update, as we know, runs every frame in runtime. Adding an execute always attribute to the class will mean that update, start, awake all also get run in the editor at the appropriate times. And so in update here, we call update camera, which just adjusts the camera's position and the camera's rotation so that it's looking at our transform. So what this does is it literally will be updating the camera every frame in the editor. So you can see I'm not in play mode, and whatever I'm doing to these properties is updating the camera immediately. Now this is kind of useful, but it's dangerous to use execute always in this manner, mainly because everything will run, as long as it's defined. If I have on enable, awake, start, if I've got something fairly expensive running an update that I need to happen in the editor, it starts getting a bit messy. So instead what we can do is potentially get rid of update here, depending on what we need it to do in the end. But for the time being, I'm just going to define a private void OnValidate method. And this calls the same update camera function. And if we save this and pop back over to Unity, what you'll see is effectively we have the same behavior. Right, whenever I change this in the inspector, this camera moves. Now, obviously, functionally, this might not be the way you would approach it, in an actual production. A camera follow would probably be an update function. It would be more of a runtime sort of method. But this sort of gives you an example of what you can do with OnValidate. Now, the next thing I'm going to look at right now is OnDrawGizmos and OnDrawGizmos selected. Now, similar to OnValidate, OnDrawGizmos it sort of falls under editor scripting, as it only runs in the editor. But like OnValidate, it lives on the monobehavior. It's another magic method. Now, OnDrawGizmos is pretty useful, as it allows you to visualize sort of ordinarily invisible data. So for example, let's take a look at this sample script here, patrol route. And I've just got it set up so that you can define a couple of waypoints and set it up whether or not they're looped. So I can set these up, and I can set a few waypoints. But on their own right now, it's not that useful. I can't see where the waypoints are. I don't know how they relate to each other. Now, obviously, implementations-wise, we could do this something differently. We could have game objects, individual game objects that represent the waypoints that we pick from. But in this case, if we just have an array of vector 3s as the waypoints, not being able to visualize them immediately is, it's kind of a drag. So let's take a look at what we can do. So if we go over to the script, we can see we just have a public an array of vector 3s. That's our waypoints, and a bool to determine whether or not this is a loop. And then we just have just a placeholder method for something to grab the position. So if we want to visualize all those waypoints, we can use OnDrawGizmos. So again, like OnValidate, all you need to do to implement this is define it. It's a private void OnDrawGizmos. There's an alternate, which is OnDrawGizmos selected, and as the name suggests, it only will draw the gizmos if this object is selected. So we're going to stick with OnDrawGizmos, and we're going to do a quick look. So in OnDrawGizmos, first thing we do is we check if waypoints is null. If it is, we just return out. And if not, then we'll loop through the waypoints. All right, so we'll run through the waypoints. And for each waypoint, we use the Gizmos class. And these allow you to draw a relatively limited set of shapes. You can draw lines, you can draw wire spheres, wire cubes. But this allows you to draw something in the scene view, optionally in the game view. Now, all I'm doing is I'm taking my gizmos, drawing a wire sphere, and here I'm passing in the position, the center in this case, and the radius. So I've figured 0.1 sounds okay. This is in world units. And for the path, I say, as long as I am not at the end of the waypoints, or if I'm looped, then I just draw a path from this current waypoint to the next waypoint. So that's gizmos.drawLine, which pass in a start point and an end point. So we save this and pop back over to the editor. We can now see a line. We have 3 points. These are the wire spheres. And this is what represents our waypoint. If I click looped, you can see it draws a line here. And we can see our waypoints. So as I move these values around, our waypoints update. If I add a waypoint, just moving it around, then similarly, everything updates. Again, if I delete this, we get an update. Now, one thing useful about OnDrawGizmos is that these gizmos are all pickable. So right off the bat, I can click on the line or any of these things, and we actually select the game object. So that's really useful, especially for, like I said, things that are typically invisible. Now, this is pretty useful, but we can make it a little bit better. So the gizmos allow us to pick and visualize. What we can't do is actually directly edit these in the scene view. All I can do is I can click on them to select, and I can adjust the positions in the inspector. It's not that useful. Next, we'll take a look at how we can use some additional editor scripting to actually adjust these things in the scene view. So now we're going to talk about what most people probably think of when they think of editor scripting. And that would be custom editors or custom inspectors. Now, the first sort of basic thing to know is that anything that needs to run as an editor script, essentially anything that uses the Unity editor namespace, is that it needs to live, the script itself needs to live inside a folder inside your assets called editor. Now, this can be anywhere. This can be a subfolder, it can be a root folder. As long as the folder is named editor, it can run editor scripts. It's one of those magic folder names that the editor uses. So to manage this patrol route component, I've created a patrol route editor script, and this lives again inside an editor folder. Now, if we jump over to patrol route editor, you can see a couple of things that are a little bit different from the usual mono behaviors. For one, we need to have a using Unity editor in the namespaces. And here, instead of inheriting from mono behavior, I'm actually inheriting from editor. And this is essentially the base class for any sort of custom inspectors. Now, some important things here. In order for Unity to actually recognize that this is an inspector for your specified component, you need to add an attribute to the class. So this is a class level attribute, and you just pass in custom editor, and you pass in the type that you want to inspect. So in this case, we have patrol route. And from here, it essentially recognizes that whenever you select this patrol route object, it will try to find this editor. Now, if we don't implement OnInspector-GUI, then it doesn't actually do anything. It just kind of draws the default inspector. So OnInspector-GUI is the sort of the legacy version of the inspector. This is how it's been done for years and years. It's the immediate mode GUI, which means it runs every frame. Essentially, strictly speaking, it's multiple times a frame. So implementing OnInspector-GUI just lets you draw your own inspector when you select this object. If you just sort of pass in base.OnInspector-GUI, then it just draws the regular default GUI. But from here, we can add stuff, right? Like, so in this case, I've added sort of a little info box using editor GUI layout, and I'm passing in a help box. So if we pop over to the editor, and I select patrol route, you can see that I've got the default inspector, but above it, I've got this little info box callout. I can add more information. I can add more controls. I can add buttons. I can add more information in a list, for example. Alternately, I don't have to actually pass in base.OnInspector-GUI. I can implement my own inspector entirely. That means I can completely, override the display of, say, this array of vector 3s. So if I wanted to give them names, if I wanted to show more information, or if I know that these are supposed to be on a flat plane, perhaps I only show X and Z instead of showing X, Y, Z. Alternately, I can run my own sort of validation functions so that, let's say, y is always going to be 0. So you can do all these things in the inspector. Now, I mentioned that this is sort of the legacy version. What we try to do nowadays is, instead of using immediate mode, we use UI elements. And as I mentioned in the slides, these are our retained mode GUI APIs. So these tend to be more performant in terms of how they're set up and sort of implemented. They can be more efficient. They're also easier to kind of restyle because the content and functionality are completely separate from the styling. Now, implementing on Inspector GUI is as simple as adding an override for it. Similarly for doing Create Inspector GUI, which is the UI Elements version. Now, interestingly enough, once you implement Create Inspector GUI, the editor completely ignores on Inspector GUI. So if you have this overridden and defined, it just gets ignored. So here we have our Create Inspector GUI. I'm essentially doing the same thing as this overridden on Inspector GUI. So I am creating a new visual element, which is the sort of the root.
Should be done by about 1:30.
I'm adding a help box, which is exactly the same as this, except that I changed IMGUI to UI elements, and then I'm drawing the default inspector. Now this is a little bit of a workaround. IMGUI container is a UI elements sort of class that allows you to draw immediate mode GUI code. So essentially you have this retained mode thing that's drawing on GUI stuff. And so since not everything that's built in has switched over to UI elements, we basically do this so that we can draw the default inspector this way. And then we return this visual element. So switching back over, you should see that this IMGUI will switch to UI elements. But otherwise, we're basically drawing the same thing. So that's the inspector portion. I did mention that one of the more useful things about having custom inspectors is being able to draw to and interact with the scene view. So interacting with the scene view or drawing to the scene view requires one thing. So in onEnable, and this gets called when the inspector essentially gets initialized. So when you first select an object, just before it draws the inspector, it runs through onEnable. So in onEnable, you'll need to register a method in during scene GUI. So scene view during scene GUI, we register this during scene GUI method. And this is where you do all of your drawing and interaction functions. In this case, since I don't need to move or rotate or scale the root game object, I'm actually also setting the tools mode hidden state to true. And all this does is it hides the default gizmos. So your transform gizmos, your move, scale, rotate gizmos. And this just means you don't get cluttered up. Importantly, in onDisable, which gets called when you deselect the object, you'll need to unregister the method that we registered earlier, and then we'll restore the tools so that we don't get the user stuck in a position where they can't interact with anything. So once we've registered this, we can jump back over to here, and this will take in a single parameter, which is the scene view. And then you can do all of your code in here, your functional code in here. So here, I'm just going to go ahead and draw the object. So I have a method here to draw waypoints. I'm passing in the patrol route object. So in draw waypoints, all we're doing here is we're just running through the waypoints in the array and doing a position handle. Now, handles class comes with a bunch of really interesting or really useful functions to draw handles, draw interaction handles, or just draw things to the screen. Some of the more sort of like familiar handles that you can do are position handle, scale handle, rotation handle. And these are pretty straightforward. You pass in for a position handle, you pass in a position. In this case, I'm passing in the actual waypoint position, and a rotation, which in this case is a 0 rotation. And it returns essentially the final position of this handle. And so this is pretty straightforward. I'm just assigning the result of the position handle back to the waypoints. Now, this part is important. If you are directly modifying the properties of an object, you'll need to use editor utility.setDirty to essentially inform the editor that these values have changed and these need to be saved. If you don't, they essentially don't get written. So there's perhaps when you save the scene, sometimes perhaps when you save out the project, you'll see that your values get lost. So jumping back to the editor, you can see that when I select this object, I now have position handles for each of these objects, each of these waypoints. So that's kind of cool. You can see the values updating in the inspector here. There is a downside though. If I move these and I do an undo, you'll see that there's no undo step actually registered. So if I undo, all it does is it undoes my selection. So that's not great. So what we can do is essentially store a hot control. Now the hot control, this GUI utility.hotControl, essentially tells you what the ID is of the currently active control, or the currently hot control as in actually being interacted with. Now these controls can be anything from text fields, float fields, sliders, or scene controls in this case. And so what we're doing here is we're checking what the current hot control is. After we're implementing the position handle, we then check again if the new hot control is different from the old hot control. If it is, that means that we know that the user is actually interacting with this handle, dragging it around, or is it at least clicked it and is holding it now. So if it's changed, or if it's active, we now register an undo. Now this undo class has a bunch of different methods to register complete object undos, creating objects, adding components. So in this case, we're just registering the complete object. We're passing in the object in question, which is the patrol route, and a message or a name for this undo step. And this will basically be your descriptive message. So once we register this this undo step, this doesn't necessarily register the step. It just tells Unity that it needs to check for changes. So if something changes, it will then essentially register a new undo step. Everything else is the same. We still got our set dirty. But if we pop back into the editor, check our undo states, there's nothing here. Now if I move this, we now have an undo modify waypoint. So if I undo that, and this will happen for every modification that you make. Now, the editor is smart enough to compose or compile different steps into a single undo step. So if you're moving or dragging a bunch of things around, let's say dragging a slider or dragging a float field, Unity will only register one step from the time that you click your mouse to the time you release your mouse. Now, handling undos manually like this it's not great. You have to pay attention to when you're registering these undos, what you're registering, and there's a lot of stuff that you need to keep track of. So instead, if we pass in a serialized object and we work directly with that, then you get a lot of the stuff built in. The undos, multiple selections. So like target, serialized object is a built-in property from the editor class. And this just represents the inspected object, but a serialized object representation of it. So here we draw waypoints. I'm doing a serialized object version. And all we're doing here is we're doing the same thing. Just doing the position handle. We're getting the serialized property for the waypoints, slightly different from the direct addressing. And at the end, once we've made any changes, or if we're likely to make changes, we need to end the frame with the serialized object apply modify properties. Now, the nice thing about this is that it is a Boolean. It will return true if anything actually has changed. And so if you need to do any, if you need to execute any functions that are based on whether something changes, you can use this as a conditional. So with just that change, remembering that we don't have any actual undo, any explicit undo code in here, I'm going to select this, and we'll see that we don't have any modifications here in my undo stack. Now I can move this, move this, move this, and I can undo this. So you can see it handles all of your undo for you, which is kind of nice. Another thing that it can do is you can also handle multiple objects. Now, the first things first, you do need to add an additional attribute to your class, which is can edit multiple objects. But once you've done that, your serialized object, you can pull for target objects, and this will give you the actual objects. So all of the objects that you have selected that match this class. But those aren't serialized objects, so you do need to cast them as serialized objects. And then we can pass them into my draw waypoints. And exactly the same now. I have multiple patrol routes. I can now select both of them, and I have handles for all of their waypoints. And these all are, again, undoable. So pretty handy. So next up, I'm going to talk about the import pipeline and how you can customize that. Now, there are effectively two ways that you can customize your import pipeline. So one is the asset post processors, and this essentially allows you to modify the pipeline, how Unity actually imports the formats that it supports. So for example, the FBX files, maybe your texture files. You can do this in a couple of stages, essentially pre-process and post-process. Pre would basically be what you can do prior to Unity actually kind of processing this this asset. You might be able to change the source size of the texture, and the post-process, which allows you to say, after Unity's imported materials of the FBX and set up its hierarchy, you can then perhaps add components to this object and do some other setup. Now, one thing to be super aware of is that when you first register an asset post processor, that means when you first create the asset post processor, you write it, and then you save it, you bring it back in, and you switch back to Unity. That's essentially the first time it gets registered. Now, when it's first registered, it will run on every single relevant asset in the project. So it's useful to know, because if you actually have a large project that you've already kind of been working on, and you want to add an asset post processor, if you're, let's say, you're not doing any conditional checks and you're doing something fairly expensive, you might be in for a wait as it tries to run on every single asset in your project. So it's kind of good to know. Good to remember to keep your conditionals in check. So popping over to the editor, I'm going to give a quick rundown. Now I've got Kenny's car kit here, and this essentially is a bunch of vehicles that have parts. They've got wheels and a body and some optional door parts. So all of these are relatively straightforward. Bring them in, and they've got a body and some wheels. Some of them have an extra door or two. But let's say I wanted to take all this and I wanted to automate certain things, like having a vehicle component added to the root, with a reference to, say, the body transform, and also references to the wheels. Now, I could do this manually for everything. I could have a script where I could sort of manually automatically add to each one, in turn. But that still seems like a lot of work. It's also a bit error prone. I need to make sure that everything is processed correctly. So instead, what if I could, on import, just automatically have these components and references set up for me? So that's partly where these asset post processors come in. So I currently have a vehicle importer, and this is set up as an inheritance of an asset post processor. So similarly to the previous one, this has to be in the editor folder, and it has the Unity editor in the usings. Now, there are a whole range of things that you can do with this. You have post-process model, post-process texture, post-process audio, pre-process model, pre-process texture. So you have a lot of options as far as how you want to handle your imports. Now, this essentially handles anything that is already supported. So you're not going to be able to do custom imports, let's say with your own file formats or file formats that Unity doesn't natively support. So implementing these is fairly straightforward. once you have this asset postprocessor class, you just implement these by defining the methods. There's no overriding or anything. So you just implement an onPostProcess model in this case, because I'm trying to automate the import of these FBX models. Now, anybody who's worked with me on a production pipeline will know that I'm a stickler for naming conventions and folder structures and whatnot. And this is where this becomes really important or really useful. So over here, we are basically checking our asset path. This is a built-in property that comes with the asset postprocessor, and it defines the path of the asset. And this is relative to the assets folder. So we're basically checking, does the path contain carkit underscore? Because I know that all of my assets that come in here are going to come in with inside this folder. Now, if they don't, then I just early out and I skip the asset entirely. I have a little message here so that in the log I know that this asset was being processed. And then further, I can check for a subfolder. So I'm not doing anything with the wheels right now, but I do have a check for vehicles. So again, anything that comes in this vehicles folder will be processed by this process vehicle method. And over here, all of this stuff is actually non-editor specific. And all this is doing is I'm just adding a component. So I'm taking my root object, which is G. This is what gets passed in. And I'm just adding components. And then I'm doing all of my processing that I need. Again, naming conventions. So I know that I can do a find for body, and I can assign that. Similarly, I can look for a wheel, and then I can set front or back wheels based on their Z position relative to the root. And that's pretty much it. The last thing I do is, in this case, perhaps I need to set it up so that I have two parents for these wheel objects so that I can steer and rotate them independently. And that's really all there is. None of this is actually editor specific. These are all just regular, monobehavior, Unity commands. Once this is done, that's pretty much it. So if I take one of these things, this ambulance, let's say, and if we drag this out in the scene, again, it's pretty basic. There's no components, and we've just got wheels and parts. If we now make a copy of this and drag it into vehicles, see over in the console, it has told me that it's processed a Kenny carkit asset. If I take this and I drag it out into the scene, you can see we have a vehicle script on it. It's got a body assigned, and it's got my front and rear wheels assigned. It's also got the correct hierarchy for the wheels. So I have essentially a steering axis, and then I have an axle so I can rotate, and then we have the actual wheel visual. And so that makes it super simple. Now, whatever I drag in here, so let's just grab all these. If I just drag them over into this folder, all of them get processed. All of them now have the correct script assigned, they have the correct references assigned, and they have the correct hierarchy. So this can really speed up your workflow, your import pipeline. Now any assets that come in don't need a manual process to kind of do all this assigning and setting up of hierarchies. So the next thing we're going to look at is the scripted importer. And the scripted importer is really just a way to handle custom file types. Now, your custom file types might be just file types that are not natively supported by Unity. So perhaps if you have specific requirements for, say, a particular CAD model type, you can kind of use scripted importer to handle that. The other thing is you could have just, custom file types that you have, they're proprietary to yourself. Let's say you have a designer that is working in a particular piece of software, and that spits out data in, a specific format, in a specific file extension. So over here, I have a very contrived example of a file type that uses the extension .item, and all it is it describes, an item. All right, so this is a type weapon, name, acts of healing, description, and cost. Again, fairly contrived. Now, without the scripted importer, this just comes in as a default asset in Unity. You can't inspect it, you can't look at it, you can't really do anything with it. However, if you add a scripted importer, and again, these will live under an editor folder, open up this item importer. This is sort of like where the magic happens. First, you need to have using Unity editor asset importers. This class will inherit from scripted importer, and you'll also need a scripted importer attribute, and this will basically be your version number. And this is sort of important because it will tell Unity that if you change a version number, it will need to check through and make sure that everything's updated correctly. If you have stuff that was imported with an earlier version number, it will re-import with the new setup. The second parameter here is the actual file extension. So in this case, .item. You have to implement on import asset. If you're using an IDE, you will get a red squiggly because this has to be implemented. So on import asset, and you've got your import context. Now, most of this is not editor specific. So all I'm doing here is I've got an item class, and this is just a regular scriptable object. It has the same structure as my item text file. Type, name, description, and cost. So all it's doing is it's creating an instance of an item. It's reading my stats file, and because I know it's text, I'm just doing a file IO to read the text. And then I'm just running through and assigning values. So the specifics of this aren't too important. I'm just reading the values. I'm treating it as a key value pair, and I'm just assigning the data. Doing a bit of error checking here, make sure that I'm handling all of the data types. And then, as again, you gotta apply your modified properties. Now, this part is specific to the scripted importer. Now, if you don't do this, this stats object essentially becomes lost. If you don't explicitly destroy it, it gets lost in memory. I think it may contribute to memory leaks. But what you're doing here, this add object to asset, and you're passing in the context that comes in from the import asset, is you're actually taking this object and you're adding it to the main asset, which is the original .item file. and then you're setting that same object to the main object. Now, the reason you do this is so you'll see that I didn't actually have to re-import this, because the metadata showed that it hadn't been imported before. And so essentially the versioning came into play. So this is automatically being imported. Now, because the scriptable object is set to the main object, it is now inspectable here. And so I have an axe, it's of type item, and it has all the data that got imported. If I were to change these, let's say I change the cost to 1,000, I save that, it automatically updates. So this is really powerful because you can bring in your own data types, you can handle your own data types. If you wanted to, you can also add a custom inspector to this, to this portion, to the item class. And this makes it really useful to just handle different types of assets. Now, there are certain limitations. One of the main limitations to the scripted importer is that you cannot handle file types that are already handled by Unity. So this means I can't register a scripted importer for FBX, for example. This is actually one of the reasons that the PSB importer, which comes as one of the official 2D tools that lets you bring in layered PSB files. That's actually the main reason why it's using PSB, because it's implemented as a scripted importer, and so PSD is already handled natively. So another thing we're going to talk about is the overlay system. Now, this is a relatively new system. I believe it was officially introduced in 21.2. And really all this consists of is ways to draw things on an editor window. By default, or most commonly, this will draw on the scene view. In fact, most of the widgets that have traditionally been here have all been converted over to the overlay system. So, for example, the orientation widget is actually now draggable and dockable. It's also dockable to the side, so you can kind of hide it if you don't need it. Similarly, things like the main toolbar, these are all now widgets, overlay widgets, which is pretty neat. You can build your own, and these can be really useful because these are things that can stay on screen wherever you need them, or they can be hidden or docked as needed. So in this case, I'm going to show a custom overlay that I built that is basically helping me work with my animation rigging stuff. So you'll see anytime I select an object that has an animation rig builder on it, this little overlay window shows me all of the rigs and the constraints that are in this whole system. This means that, let's say, while I'm in play mode or in animation mode, I can turn the weights of each of these constraints down as needed. So this makes it a lot easier if I'm, building or modifying animations to actually have all of my constraint weights here, without having to select them individually, without having to select each object individually. Because these are tied directly to the weights, these are also keyable. So every time I do this, I can automatically key them. So let's have a quick look at what that looks like. So you'll see over here, my class inherits from overlay. Now this overlay lives in the Unity editor.overlays namespace. Similarly, we have an attribute. So you'll see this is fairly common among a lot of the editor side things, where you'll have editor and then custom editor. Here we have overlay and overlay attribute. The parameter you pass to this, the first parameter, is actually the type of window. As I mentioned earlier, quite commonly this is the scene view, but you can also pass this to really any editor window. If you have a custom editor window, you can use an overlay on that. And this is just the name that shows up. So overlays effectively don't have an OnGUI or an immediate mode GUI method. These are really built all around UI elements. So here we have, we are overriding the create panel content, and this is where we create our content. Now, a lot of the overlay stuff works using, typically, a lot of these basically using selection changed. This is a built-in editor callback, and essentially anytime you change selection, you select something new, you add something to a selection, remove something from a selection, this delegate gets fired. So you can subscribe to that delegate in order to do things that you need to in this panel. So right now all I'm doing is anytime I update my selection, again, most of this is non-editor specific. There's a lot of code here, but primarily it's just kind of running through, looking for all of the rig builders, or looking for the main rig builder, running through and looking for all the layers, and then looking through for all of the constraints, and then just really binding all of my controls. But what I end up with, because I'm actually binding these controls, so I'm binding my progress bar, for example, to the weight property of each of the constraints and each of the rigs. Because I'm binding those, what that means is not only am I controlling the weight of the rig from this slider control, this slider control also updates when I directly change the rig's weight. So as I bring it down to 0, my slider also updates. So this becomes super useful because it's something that I can have floating around while let's say I'm animating this thing. I can also have it docked if I don't really need it all the time. I just click on that to bring it up, make my changes, and then it hides again as I, go somewhere else. So super useful. And again, a lot of this stuff is built with the overlays interface, the overlays API. So this toolbar over here that you can dock, the orientation widget, and you can build your own. There's a search overlay. You can do something really dirty like make an inspector overlay. So I know that was a lot to take in. There's still so much more to cover as well. But if you have any questions, I'll be happy to field them in the time we have remaining. In the meantime, thanks for sticking around.